The topic for discussion in this video lecture is it's about the foundation for the beginners. So, what is robotics and what is automation? And this is Dr. S. Mohan Lakshmi, Professor and Head, Department of Electronics and Communication Engineering from Rohini College of Engineering and Technology. On completion, the students will be able to explain the types of robots, explain the Robo Anatomy. They will be able to explain where the robots are really applied. So, what is robo? It's an electromechanical device which can be reprogrammed. It is multifunctional. It is sensible for environment. It can carry out variety of tasks. So you could see in these slide, we have shown different types of robots over here. So which is a manipulator, which is a very essential part of a robo. It's a type of a robo. In the sense, it can pick. So for example, pick and place robos. So where this could manipulate a certain task. And this next one, it's legged robo, where it could walk. And similarly, wheel robo, where it will be having the wheels. And similarly, the last one is the walking robo. And coming to an introduction aspect, so how do we define a robo? It is defined as a computer controlled machine with some degrees of freedom. So, what do you mean by degrees of freedom? It is the ability to move about in its environment. So, robot typically it will have the sensor to sense its environment. It will have certain goals. Then it will have a planning. So, to determine how to accomplish those goals, and it will be having the path planning to determine, so in case of moving robots, how to move about its environment using the available degrees of freedom. So this may be the motion of arm to pick something up, or it may be a series of movements where physically it will move it from location 1 to location 2, say. Okay. So the robo usually have a three-phase sequence of operation. So one thing is, first one is it will sense, which is a perception, and the second one is process, which is it will interpret and it will plan accordingly, and third one is action. So it is movement of some kind. So either it can pick and place, or it can move from one place to another, or it can rotate, whatever it is. So why we need robos? So one thing is a speed. So the man cannot do to that much speed, so the robots can do it. And certain places the human beings cannot enter, which may be hazardous or dangerous temperature. So in that place, robots can be deployed. And suppose we want to do any repetitive task, so the normally the human being will get bored of. So we can do the repetitive task with accuracy using the robots. And similarly, any work with accuracy, we can rely on the robot. And this, some of the pictures I have shown you here, this is used in the planets even in the space. This you call it as planetary robotics. And here you could see a type of humanoids. So where it will resemble the human being, and it is entirely autonomous, where it can do its own function. So here you can see here the first one is a humanoid, which is actually the name given to that robo is Sophia, where it could even have the emotions. And here you could see certain humanoids which is doing certain works like cleaning, picking up and taking, moving the trolleys, all these things. And how these robots are classified. So we have basically two types of classification. One is based on the Japanese Industrial Robo Association, other one is American. The first one you call it as a JIRA. So where we have class 1 to class 6, where the class 1 is a simple manual handling device, class 2 is a fixed sequence robo, class 3 is a variable sequence robo, class 4 is a playback robo, and class 5 is numerical control robo, and class 6 is an intelligent robo. So you could see from the name itself, you could understand what it is actually. So playback robo is nothing but like once first you will guide that particular robot to do this task, and immediately all those things get stored, and from the next time once it operates, it will take off all the messages or all the commands it has taken, and it will automatically work. And coming to the Robotics Institute of America, which I told in the previous thing, RIA, it has considered only classes 3 to 6. And here they classify it as type A, type B, type C, and type D. So type A is handling devices with manual control to telerobotics. Type B is automatic handling devices with predetermined cycles. So this will know how many times it has to take. For example, I need to pick up certain material 500 times and I need to place it after 1 meter or something like that. So that is predetermined. And similarly, the type C is a programmable server controlled robots which will have point to point trajectories preferably. And type D is very similar to type C, but it will be having the capability to acquire many things in the environment. And what are the basic components of Robo? So, as I told you, the earlier also I've shown you a thing which is a manipulator or a rover. So, this is the main body of the robo, and it will consist of links and joints, and this forms the structural element of robo. And the second important thing is actuators. So, this is like muscles of the manipulators, and normally we go for some electrical drives, or that you call it as or the common types used are servo motor, stepper motor, pneumatic cylinders, and end effector. So end effector, this is a part which is a last, which is connected to the last joint of a manipulator, and normally this will handle the objects. It will make connections to other machines or it will perform the required task. It can vary in size and complexity, where it can fall from an end effector on the space shuttle to a very small gripper. And these are the robo components, as I've told you already, which is sensors. And you have the processor, you have the controller. Of course, we know sensors. This is about it will collect all the information about the internal state of the robo and it will communicate to the outside world. And robots are often equipped with external sensor devices such as like vision system, cameras, touch and tactile sensors. And similarly, you will be having a controller, which is nothing but you will be having a computer which will control all the motion of the actuators, and it will coordinate this motion with the sensory feedback information. And similarly, a processor, this forms the brain of a robot. So this you want to calculate the motion of a robot joints. So this is probably it will calculate all those things, and that will be utilized. And other important aspect is software. So the three groups of software is used in robo. So one is operating system, which will operate the computer, and the second one is robotic software. It will calculate, as I told you, it will calculate all the necessary motions of each joint, and it will inform the controller. Maybe at different levels. So you can have right from machine language. There are certain languages for the robots, and even it can fall into sophisticated languages used by modern robots. And the third software will be used in collection of routines and application programs. So these Robo Anatomy and what are the related attributes? So when I talk about the anatomy of robots, it deals with the assembly of outer components of a robot, such as a wrist, arm, and body. So you can imagine ourselves. So suppose if I take a hand, we have a wrist, we have an arm, and we have the fingers. So similarly, like this, the very important components over here is joint and links, and based on this the different configurations are made over here. So we have certain robo configurations. So here manipulator of an industrial robo will have a series of joints and links. So robo anatomy deals with study of different joints and links and other aspects of physical construction. A robotic joint provides relative motion between two links of the robo. So each joint will provide certain degrees of freedom. So mostly if you have one joint, there will be 1 degree of freedom. So if you have three joints, there will be a 3 degrees of freedom. So robo complexity can be classified according to the total number of degrees of freedom they possess. So each joint will be connected to two links. So one will be an input link and the other one will be an output link. So from this figure you can see there is a robotic base here, connection which is connected to the first joint, which is termed as link 0. Then the first joint in the sequence, you call it as joint 1. Similarly, you have link 0 is the input link for joint 1, while the output link from joint 1 is link 1, which leads to joint 2. So this joint link numbering scheme is further followed for all joints and links in the robotic system. So you have links and the joints, which is the very important component or of the robo. So here coming to the joints and links, nearly we have all the industrial robo have mechanical joints, which is classified into 5 types as shown in figure below. So this may be a linear joint where it can move linearly, orthogonal joint, you have a rotational joint, you have a twisting joint, and finally you have a revolving joint. So here according to the movement of the robo, these joints are used. So linear joint, you call it as type L joint. So there will be a relative movement. So there will be a relative movement between the input link and the output link. It is a translational sliding motion. Okay. So where the axis of two links being parallel. Similarly, once I go for orthogonal joint, you call it as a type U joint. This will be having a sliding motion, but the input and output links will be perpendicular to each other when they are moving. And similarly, the third one is a type or joint, which is a rotational joint. So this also have a rotational relative motion, where the axis of rotation will be perpendicular to the axis of the input and output links. And once you come to the twisting joint, which I call it as type D joint, so this involves a rotary motion, but the axis of rotation will be parallel to the axis of the two links, unlike the previous one. Revolving joint, which we term here as V, and here the axis of input link is parallel to the axis of rotation of the joint, and the output link axis will be perpendicular to the axis of rotation. And coming to the robo coordinates, so here the configuration, it will follow certain coordinate frames. So before we go into the configurations, we should know how it is denoted. So prismatic joints, it is denoted by P. Revolute joints, it is denoted by R. Spherical joints, it is denoted by S. And suppose if a particular robo is having 3 prismatic and 3 revolute joints, then it is specified as 3P, 3R. So for configurations which is used for positioning the hand of the robo, we have this type of 5 types of configuration, which we call it as Cartesian, cylindrical, spherical, articulated, scara. So in the brackets, the respective number of joints are given. Say for example, in the first case it is 3P, which is 3 prismatic. In the spherical joint, you can see 2 revolute and 1 prismatic. So from this figure, you can see here the various configurations are given. So this is once again how it is movement. So in the Cartesian, as I told you, it is a 3 prismatic. Prismatic in the sense it is a linear joint. So you can see 3 arrows in the first diagram, which will be moving in 3 linear directions. So once it is given with a rotating arrow, then it means a revolution or rotation. So robo specification. So what does the robo characterize, or how it is characterized? So one first thing is payload. So how much weight it could carry, a robo could carry. Second thing is reach. Reach is nothing but it is the maximum distance a robo can reach within its work envelope. Work envelope is nothing but like how much it could utilize the space. So here also we have 2 types of reach, which is vertical reach and horizontal reach. And here the functions of the robo's joint length and its configurations depend upon this particular reach. And third aspect is precision. It's a validity. How accurately a specified point can be reached. That you call it as a precision. So function of the resolution of the actuators and feedback devices depends on this precision. So most industrial robots have precision of 0.001 inch or even better than that. So even if you have certain error, and if it is going to be consistent, we can eliminate it. And similarly, the other two characteristics are repeatability, which is a variability. So, for example, how accurately the same position can be reached. Suppose I want to pick a particular material and I want to replace it somewhere else within 1 meter, or say specifically at 1 meter. Then suppose 500 times it is performing. So the 500 times it has to do in the same time, and it should not deviate the distance. So that you call it as a repeatability. So how far it is accurate once the task is repeated. Then the final thing is spatial resolution. Spatial resolution is like how the robot could break down its movements into increments. So normally we have a range, and that is specified, or spatial resolution. You can even define it as range divided by 2 power n. So that n will be the movement of steps, or how much it could break down. And once we use the robots, obviously there will be a social and ethical issues. So using the intelligent machines in our daily life, obviously it will bring these problems. So where this is summarized as sensitive task. So normally sensitive task will require human supervision, and humans will no longer take any responsibility for any failure in the robot. And obviously this will reduce the employment and de-skill the workforce. So nowadays artificial intelligence has entered, and it is dominating the robotic world, where it could erode the human freedom. So there are chances of using the AI in unethical ways. So where normally the robots are utilized. So normally in the machine loading, we can place welding, painting, assembly operations, manufacturing, surveillance, medical applications, assisting disabled individuals, hazardous environment, underwater, space, and remote locations. Thank you.